Welcome to the Woodbridge Geometry Virtual Tutor. You are in the right triangles and trig unit. You'll be focusing on applying sine, cosine, and tangent inverse to find the missing angle in a right triangle. So how we would go about finding a missing angle. We've already talked about how to find the missing side of a triangle given an angle and a side. So that was your previous material where we had sine, cosine, tangent. You had one side length and you had a given theta or a given angle, and we had to cross, multiply, and solve. But now the question arises, what do we do if we need to find the angle given two sides? We used what is called the inverse of our trig functions. So that brings us to the question, what is the inverse of sine? This is used when we're trying to find an angle. It answers the question, what angle has the ratio equal to our opposite over our hypotenuse? So O over H. So why is it O over H? Well, that goes back to SOHCAHTOA. We know sine is opposite over hypotenuse. That's coming from the O and H. You're dividing the two sides. So when we're working with sine, it's going to be written as the inverse of sine. So it's sine raised to the -1. And then all you're doing is putting in that ratio, O over H. So we can find this in your calculator by hitting the second sine button. So remember, when we're working with trig, we always have to set our calculators to degree. So you have to go into your mode, make sure your calculator is set on degree instead of radians. Remember, the default setting on a calculator is going to be radians. So on a test, SOL, quiz, warm-up, practice, etc., you need to change your mode to degrees in order to get the correct answer for trig. All right, so basically, the sine function takes an angle and gives us the ratio. So in this visual, we have the angle, sine is taking it to give us that ratio of opposite over hypotenuse. We know sine is O over H. The inverse of sine takes the ratio and gives us an angle. So it's working backwards. So we're taking the ratio, then we do the inverse to get the angle. Again, it works backwards. And this applies for cosine and tangent. It's going to work the same exact way, except you're going to take the inverse of cosine. And when we're working with cosine, we know cosine is equal to our adjacent over hypotenuse. So if we were taking the inverse, we'd take the inverse of cosine of A over H. If we were working with tangent, we know tangent of theta equals opposite over adjacent. So then we would take the inverse of the ratio, actually O over A. There we go. So it's going to apply both ways. And again, the calculator must be in degree mode. So looking at number 1 here, we're going to set this problem up same way as previously. I want you to stand or think of yourself standing at the angle that they give you. So that angle's unknown, but we know the 90 degrees there, and we have to solve for that question mark. First thing we're going to do is go ahead and label our sides, H, O, and A, hypotenuse, opposite, and adjacent. So we know across from our 90 degree is our hypotenuse. Across from where we're standing is our opposite, and next to us is our adjacent. Now we're going to look at what sides they gave us. They gave us a 28 and a 41. Thinking back to our SOHCAHTOA, we ask ourselves, which trig function has O and A involved? O and A, that's tangent. So we know tangent of theta equals opposite over adjacent. Now we substitute in what we know. We have tangent of theta. We don't know theta. That's that question mark. We're trying to find that angle. We know our opposite is 28, and our adjacent is 41. So at that point, we're trying to find an angle. So anytime you're working with trig and you're trying to find the angle, you have to take the inverse. So we're going to go ahead and take the inverse of tangent of 28 over 41. At that point, you can go ahead and take out your calculator. And you need to make sure you are set back in degrees. So in order to do that, you hit the mode button. So we hit mode, we go down, we see radians not highlighted, it's highlighted on degrees, so we're all set to get going. So tangent, we're taking the inverse, so we're going to hit the second tangent button to give us the inverse, and then put in 28 over 41. Close parentheses and enter. So we get 34.33 is our answer here. So we know theta is equal to 34.3, and this is in degrees, it's an angle, so always make sure you put a degree mark back on it. Let's go ahead and look at number 2. You're standing at that unknown angle. Cross from the 90 is our hypotenuse. Across from you is your opposite, and next to you is your adjacent. They give us two side measures. They gave us that H, that's a 32, and they gave us the O, 27. So you're thinking about SOHCAHTOA. So we have H and O. The trig function that uses H and O is sine. So we're going with sine of theta equals our opposite over our hypotenuse. We don't know theta, so we're going to leave it in there. So sine of theta equals our opposite. Opposite was 27, all over our hypotenuse of 32. We need the angle. Anytime we need the angle, that means we have to take the inverse of the trig function we're working with. So we're going to take the inverse of sine of 27 over 32. So at that point, you can go ahead and grab your calculator. And let's go ahead and take the inverse of sine. So to get the inverse on our calculator, we hit second sine. There's sine with a -1. And we just put in our ratio. So 27 divided by 32. Enter. And we found theta. So theta comes out to be 57.5 degrees. Again, it's an angle, so make sure we always put a degrees on that. 3 and 4, I want you to hit pause. Go ahead and try to solve these by yourself. So identify your sides, H, O, and A. Determine what trig function you're using, and then go ahead and take the inverse. So hit pause and work through these two examples by yourself. All right, so hopefully you were able to label your H, O, and A, identify what trig function, and then substitute in. So looking at number 3, based on what they gave us, we know this was a cosine problem. They gave us a 23, which was your adjacent, and the hypotenuse of 45. So cosine of theta equals adjacent over hypotenuse. So cosine of theta, we substitute in, is 23 over your hypotenuse of 45. So now we're finding the angle. Anytime we're finding the angle, we know we have to take the inverse. So you're going to say the inverse of cosine of 23 over 45. At that point, you can pull out the calculator and we can type in second cosine to get that inverse. Let's delete that. There we go. Second cosine of 23 over 45. So you just put right in the ratio, hit enter, and we found theta. So theta here is 59.3 degrees. Remember, it's an angle, so we always need degrees on it. Number 4, hopefully you identified your sides and realized this was a tangent problem since we had the O and the A. So tangent of theta is equal to opposite over adjacent. And then we just plug in what we have. We're missing the angle, so we leave in theta. Your O value is 35, so your opposite's 35. Your A value is 47. So you substitute in for your adjacent. Now we need to find the angle. So anytime we find the angle, we have to take the inverse. So the inverse of tangent of 35 over 47. And we type it right into the calculator. So we hit second, tangent, maybe, there we go, second tangent. And we put in our ratio 35 over 47. And that gives us 36.7 degrees. So theta is equal to 36.7 degrees. So hopefully this practice has helped you guys. Remember, when you're solving for an angle, it's always the inverse. So you want to identify where you're at the theta or the unknown angle. From there, label your sides HOA. Identify what two sides they give you in the problem. Pick out your trig function, sine, cosine, tangent, and then take the inverse of that trig function. And make sure always your calculator is in degrees.